So, what you Abdel? You
Cool. Well, hello everyone. Thank you for having me. And yeah, so we're gonna do an introduction to Ambient Mesh. But before I go there, I will explain for those of you. We have a few people on the call. So if you don't know what Istio is and what Service Mesh is, I'm gonna cover it on a very basic level, so you understand what Ambient Mesh is and what it does. I'm gonna do also a couple of demos, which I think are important to understand where is this whole thing come from and why are we talking about it. Since I talked with Muslim and Yusuf, and you guys are all, or everybody here, or everybody who is member of Group B's is some sort of consultant in some company, I just want to start by saying this. Ambient Mesh is not production ready. So do not go recommend this to your customers. So think of this as something that will become your problem in a few years. It is a very interesting new architecture for Istio that is going to solve quite a lot of problems that already exist in Istio, but it is not. It's still pretty much in experimental. It is pretty cool. So my name is Abdel. I'm a cloud developer advocate with Google. I've been at the company for almost 10 years now. Done quite a lot of things. Started actually in data center, and then I done a little bit of consulting, and then now I do I do Kubernetes stuff and container stuff. I co-host a podcast called Kubernetes Podcast by Google, and I'm a CNCF ambassador. And so, for those of you who know what Istio is and how it works, we are probably familiar with this architecture. This is the current architecture of Istio as it stands. This is what we typically refer to as sidecar full architecture. So in a Kubernetes world, a sidecar is usually in a proxy, in a container that runs alongside your main application. In this example, the sort of like gray rectangle is the pod. Inside of it, we have service A, which is application container, and the sidecar is a proxy. And so in a sidecar full architecture, every single container, every single pod in your system will have the application pod, the container, and then a sidecar container. And the way Istio works is that the traffic that is going in and out of your container application is intercepted by the sidecar. And then that's where all the magic, if you want to call it, of Istio comes into place. Then there is a control plane, and the job of the control plane is to configure the sidecars. But before and then normally you would have those special proxies. We call them ingress gateway and egress gateway. I'm not going to spend too much time on those today. But I want to take a step back. And before we even get any time further, what is a service mesh? Why do people actually create the service mesh, right? Like, what's the whole deal with the service mesh? So a long time ago, let's just assume you're a developer and you work in a company and you have two applications, two containers, two VMs, doesn't matter. They talk to each other on HTTP, gRPC, TCP, whatever, right? Your boss comes to you and says, I think we need to put MTLS. Because I read in some piece of paper that MTLS is cool and we need to do it, right? So for those of you who doesn't know, MTLS stands for mutual TLS. So if you're coming from sort of the networking security background, TLS existed for a very long time. It's the encryption protocol where the client, in this case, maybe service A, we can consider service A as the client, would talk to service B, do what we call a TLS handshake. And part of the TLS handshake, it would verify the identity of service B, and then download the public key and use that public key to encrypt traffic that it will be sent to service B, and the service B will use its private key to decrypt the traffic. MTLS is the same exact concept, but happens both ways. Both services have a key, public and private, and both exchange the public portion of their keys so that the traffic is encrypted in both ways, and it's authenticated in both ways. And this is a relatively new way of doing it, and it's part of like a big movement called zero trust, where in an environment you do not trust the wire, which is basically the data path, the network path. So you add MTLS between services to make sure that there is encryption and there is authentication. Doing this between two services that are running on two virtual machines is relatively easy. Doing it at scale, if you have thousands and thousands of virtual machines or thousands of containers, is complicated, right? One of the basic things would be, what if your key is leaked and you need to rotate it? How do you rotate key in an environment that contains multiple hundreds or thousands of containers? So the idea of having a control plane, a centralized control plane that would do certificate management, becomes interesting in this use case, right? So we do all certificates management in a central place. That central place is responsible for issuing and rotating the keys and distributing them. And since that central place can do certificate management, we can also make it do things like policy enforcement, telemetry, routing, etc., etc. And so a long time ago, maybe 20 years ago, people started implementing this using libraries. There are actually libraries in different programming languages, mainly Java, especially Java, that can do MTLS. So you import library, you have a function, you just write your function, you tell the function what is the key, and the library will implement the MTLS for you. The problem with this approach was that that library is code. And that's code that you have to maintain, and then you have to upgrade, and you have to be responsible for. So that's when people started realizing, well, why don't we make these functions like encryption, policy enforcement, etc., an infrastructure problem instead of it being an application problem? In other terms, why don't we offload these functions to a third-party process, which would be a proxy in this case, and that third-party process will run alongside the application and implement all the features, right? So the applications themselves, they can continue talking plain text, so HTTP. The proxy will be responsible for intercepting the traffic, so basically sitting between the applications, and then receiving the clear text traffic, and then applying policies that that proxy is configured to apply to that traffic. And that's the whole point of Istio, right? That's how Istio was created. Istio uses a proxy, which is called Envoy. Envoy was not actually created by us, by Google. It was created by Lyft, which is an American company that is kind of like Uber, but just American. So they created Lyft, and they created, Envoy. And Envoy was created by Lyft to solve sort of the same exact set of problems. They needed a lightweight proxy that could scale. So Envoy is written in C++. It's very lightweight. And the second thing which is very important with Envoy is that, which makes it very different than all the other proxies you have seen before, you do not configure Envoy with configuration files. You configure it with an API, right? So if you want to make configuration changes to the proxy, to the Envoy proxy, you have an API. And this API have like multiple names. There is like one term that we use to describe those APIs. We call them XDS. So the XDS API, XDS, that's basically the set of API that Envoy implements in order for it to do its configuration changes, or also for it to export some telemetry and stuff like that. And so, so that was the proxy. And then some people got together and they said that we were just gonna write a control plane which can understand and can configure proxies at scale. So the idea here is that you have a control plane. That control plane, you can configure it using YAML file. We're going to see that later, because Istio technically was created for Kubernetes. So then the control plane can be configured using a text file, a YAML or whatever. And that control plane understands how to take the configuration that you give it and translate it into something that Envoy understands, right? So in an Istio-based environment, all the proxies talk to the control plane, and they listen to the control plane for configuration changes, and they also send telemetry to the control plane, right? So typically the way Istio works is that you would deploy it in a cluster. So you deploy the control plane, you would deploy your application, in this case, service A, service B, etc. And then you have two options to have that proxy added. You can either add it yourself manually. So you take your YAML file for Kubernetes, and then you add a section for a second container, and you say, okay, proxy, blah, blah. Or you can do something called sidecar injection. So sidecar injection is a process by which you deploy the app, and the sidecar will be automatically injected for you. Yeah, so sidecars give us like a very good way of improving how do we get the benefits of the mesh. By the way, before I move on, the reason why a service mesh is called a service mesh, it's because in a point-to-point communication, so when you have multiple containers that all have this Envoy proxy injected in them, and when they are talking to each other, there is no single point of, there is no load balancers, basically. So essentially, in a service mesh environment, every proxy knows where every other proxy is. and talk directly to that other proxy directly. You know that in Kubernetes, every pod has an IP address. The proxy has the IP address of the pod. So every proxy in my environment, in Kubernetes environment, knows the IP address and the port of all the other proxies. So that's why we call it a mesh, because there is, when you look at how the data plane works, there is actually like a mesh of communication. There is no single point of, like, there is no basically load balancers in between. It does not use the typical internal load balancers of Kubernetes for the communication part. It uses it only for service discovery. So the sidecars have a couple of problems, right? Sidecars are very invasive because they have to literally be injected or inserted into the workload. If you want to upgrade them, you have to restart the pod. So as I said, configuration changes for Envoy can be hot reloaded, so you don't need to restart the proxy when you do configuration changes. But if you want to upgrade the proxy, if you want to bring up a new version, you have to restart the whole pod, right? And you have to restart everything. It has couple like Ambient Mesh was really created to solve two main problems. Main problem number one is over provisioning with resources. So in an environment that has proxies, those proxies are containers and they consume resources, right? They need memory and CPU. And as I said, they are sidecars and they run with every container or every pod in your system, which means if you have an environment which has 1,000 containers, if you add Istio, suddenly you would have 2,000 containers, right? And those extra 100 container needs memory and needs CPU. So they consume resources. And then the second thing is that they break some, sometimes they break some HTTP implementations. So your screen is still visible. Oh, okay, cool.
Il y a un problème.
But
I just saw 𝐬𝐧𝐭𝐲𝐡 sharing his screen.
oh,
He shared his screen.
What's going on, Saïd?
Ouais.
Hey, come on, guy.
Ouais, il a partagé son écran sans faire exprès, je crois.
Ouais.
Let me share it again. I think it's good now, right?
It's good. Yes.
Okay, good. Cool.
Thanks.
So the other problem that sidecars have is that when you have an environment where you have a sidecar, basically your application cannot talk on the network unless the sidecar is available or until the sidecar is available. In other terms, if your application, your container, when it boots up, when it starts, it needs to issue an API call. It needs to talk to a remote configuration server or something like that. If the proxy is not ready, the proxy is not fully booted and bootstrapped and configured, then your application will just fail. The network would not work. That's because the traffic has to go through the proxy has to be ready. And this was especially a problem in Kubernetes because up to very recently, by very recently, I mean, I think version 1.27, which is the last version, there was no way in Kubernetes to decide the order in which containers start. So if you have a pod and you have multiple containers in it, you cannot configure the containers to start in a specific order. And you cannot also create dependencies. You cannot say container A will not start until container B is ready, whatever ready means in your case, right? So this was a problem. So it was a problem for if you have, as I said, an application where the application has to do has to issue a network call as part of its bootstrap. It's a problem also if you have those like fast-lived containers. So imagine you have like a CI job, and the job itself takes, or maybe like a pipeline. So you have an actual cron job that executes some calculation, and the job takes 10 seconds. You add the proxy to it, and then suddenly you increase your runtime from 10 seconds to like a minute, because the proxy has to get ready. And then once your job finishes running, then the proxy also has to be cleaned up. So it basically had a couple of challenges, right? So about 2 years ago, some people in the Istio community started discussing how can we solve this, right? And the goals they had in mind were, we want to have a non-disruptive data plane for application. So essentially, when you enable and disable the control plane or the disabled data plane, enable disable MTLS or whatever, that has to be non-invasive for the application itself, right? Easy to upgrade. You can basically upgrade the application without having to care about the service mesh and vice versa. It had to still be compatible with sidecars, with sidecar-based Istio. There is a reason for this, is because if you are, so the path forward with Ambient Mesh would be that you don't just replace the old, well, like the sidecar full architecture with Ambient Mesh. You can enable Ambient Mesh in an existing service mesh and migrate slowly. So the two have to be compatible with each other. And so the architecture had to come up with removing sidecars. And basically what they realized was that a service mesh essentially does two distinct things, right? It has a security aspect to it, or at least Istio. It has a security aspect, and then it has a layer 7 processing aspect. So on the security aspect, that's basically the MTLS stuff, right? So when you install Istio, you enable MTLS. That's just the underlying MTLS part, and that could be implemented without all the layer 7 stuff, right? You don't need all the HTTP routing and load balancing and fault injection, all the features that are done at layer 7. If you don't need them, you don't have to enable them. And so the idea would be, why don't we split these two set of features into two different proxies? So one proxy will implement only the layer 4 stuff, and that would be a proxy per node called 𝐸_tunnel. So it's the name, it's a 𝐸_tunnel. It runs as a daemon set. It runs one per node, and it implements the features at the node level. And then if you need L7 policies, if you need to have authorization policies or whatever, then they added a new thing called a waypoint proxy. And so a waypoint proxy is a proxy per namespace. I'm going to show it in the demo later. But basically, it's a proxy that can implement L7 policies on the namespace level. So this is how it looks like in the new architecture for Ambient Mesh. You have a cluster, you have a set of nodes, and then on each node you have a tunnel called 𝐸_tunnel, which is a node level proxy. The proxy 𝐸_tunnel implements all the layer 7, all the layer 4 stuff. So if you have MTLS, for example, and S1 is talking to C2, it's still the same model. S1 will send clear text traffic. The 𝐸_tunnel intercepts that traffic, encrypts it, send it to the other side, and then the traffic is decrypted before it's sent to its destination. Then if you enable an extra policy, then there will be a waypoint proxy, which is a proxy for the namespace. And that proxy will implement or will have all the layer 7 policies. I know that this is not probably pretty clear. It's going to become clear when I do the demo, when I show how it works. Typically, when you deploy Kubernetes, as I said earlier, you do this thing called sidecar injection, which is essentially you have each pod, and each pod has a proxy running next to it. You can also enable it in either manual or automated way. In Ambient Mesh, there is no sidecars. The 𝐸_tunnel is running all the time on the node, and then whatever pod runs on the node has to send traffic through the 𝐸_tunnel. There is a CNI, a container native interface, and the CNI, which is the Istio CNI, allows basically to reconfigure the network in a non-invasive way. So if you enable MTLS, if you enable the 𝐸_tunnel, then the CNI will be able to forward or route the traffic to the 𝐸_tunnel without the nodes or the pods or the workloads having to care that it even exists. And one of the key things also is they are using this protocol called HBond. So in the old traditional Istio proxy trafficking, if you have two containers, C1 and S1, and then you have two proxies, every single connection creates a new TCP flow, right? So if C1 is like for every new connection on a specific port, there is a new TCP flow that is created. The 𝐸_tunnel doesn't do that. The 𝐸_tunnel actually creates one tunnel between the proxies, right? And that tunnel is used to multiplex all the TCP connections coming out of the containers, right? This is actually very good because it reduces the MTLS overhead, because the MTLS has obviously more overhead than regular TLS. But since there is only one TCP connection on port 15008, and MTLS is already enabled on that connection, then there is no overhead. When the pod or when your container sends it traffic, it gets to the proxy, which is the 𝐸_tunnel, which then routes it through the existing encrypted MTLS. So let me show you how it looks like. I have already deployed. I have already deployed. I hope you can see my command line. Maybe I can just go a little bit bigger like this. All right, so let's start with some basic stuff, right? So if I look into the Istio system namespace, I already have a bunch of things. I have Istio-D, which is the control plane. That's the old school control plane. I have the Z tunnels. They are there. And then I have the ingress gateway, which you don't worry if you don't know what the ingress gateway is. It's just the way to get traffic from outside the service mesh to inside the service mesh. I deployed 𝐾𝐬𝐸 and Prometheus just for the sake of testing. And then I have an app deployed in the default namespace, which has multiple, multiple containers or multiple pods. And you can see here, each pod is only running one container inside. So there are no sidecars, right? I have also, I think, I have also labeled the namespace. So I'm going to go ahead and unlabel it just to show you how this whole thing looks like. Give me a second. You still need to label the namespace like you used to do for Istio for the mesh for the ambient mesh to work. And let's go ahead and do this. So I'm going to go here and which one is it? Hold on. One of those should work. kubectl get svc -n Istio system. Yes. On. Oh, it's not working. Okay. One more second. Let's see. There is a gateway. Okay. But things are not working for some reason. Blah, blah, blah. This is deployed already. So I have to remove the delete -f auth z.yaml. Oh yeah, good. Now it's working. Okay. So this is just a very simple app. It's basically, the app itself is composed of multiple microservices. There is the microservice, which is the landing page. There is a microservice which provides the reviews. There is a microservice which provides the rating, so the stars. And then I think there is a microservice which is for login, and that's it. But it doesn't matter. So this is our app, right? Now I also have something called 𝐾𝐬𝐸, which is, so if you don't know what 𝐾𝐬𝐸 is, it's just like a dashboard. It allows you to run. Give me a second. Good. It allows you to basically get like a visualization, like a graph, so you can visualize the applications. So I already deployed it. It's already here. So what I'm gonna go here and just update this page to generate some traffic. And if I go back to 𝐾𝐬𝐸, I can probably see at some point eventually stuff that will show up. Come on. Yeah, graph. I don't want to see this part here. Fine. Just updating the landing page so I get some. It should just work, but it's not working for some reason. Come on. Okay, let's give it a second. I don't know what's going on. That kind of breaks my whole demo, because that's the whole point, is to show 𝐾𝐬𝐸. Okay, it's not working for some reason. I don't know what's going on. I am on the, yep. I'm on the right place. Okay. I don't know what's going on. But normally, normally this would show us basically the did I miss, hold on a second, did I miss something?
It's okay. It's a classical demo effect.
Exactly.
No worries.
But I still want to show it. Just give me a second. Let me just do something really quick.
Go ahead.
Yeah, so the app is working actually. You can see that the app is working. Okay, no, it's not working. Whatever, it's not working for some reason. Maybe let's go ahead and enable. Yeah, sorry. I know why. Because I didn't have the service mesh enabled. So that's why. Namespace did not have the service mesh enabled, so it's obvious it's not going to show anything. Yeah, here you go. This is what I was looking for. Okay, so 𝐭𝐤𝐡, what it does basically is that it looks at the, it monitors the traffic between your applications, and it just gives you a visualization. So you can see I have the product page, it talks to the details page, and then it talks to the reviews page. And then the reviews page has like 3 versions, like 1, 2, 3. So here is one interesting thing. You see here what I did is I took the namespace defaults and I just added the label called istio.io/data plane mode equal ambient. For those of you who are familiar with Istio, in the current architecture of Istio, this is how you would enable sidecar injection. You would label namespace, but then if you have a namespace which already have apps deployed in it, and you want to enable Istio, you would have to install the control plane, enable sidecar injection, and restart all your pods. Here, we didn't have to do that. We didn't have to enable or restart pods. I just enabled Ambient Mesh, and I can already go here and turn on security, and I can see already that the traffic is already encrypted. So this little dot here, this little lock here in 𝐭𝐤𝐡 says MTLS is enabled. That's it. I didn't have to redeploy the app. I didn't have to do anything, right? So that's the Z-tunnel and the whole magic of the CNI. I turned on a label, said I want to enable Ambient Mesh in this namespace. The CNI will forward traffic to Z-tunnel, and then the Z-tunnel will encrypt the traffic as it goes between applications, right? Then one other thing that the Z-tunnel can do is that it can do some very basic authorization. So here is an example where we implement authorization policy. So the authorization policy is applied to the product page. It allows, what does it allow? It allows 2 identities. One is called sleep, and one is called Istio Ingress Gateway Service Account. So basically what we're saying here is we want to allow talks or calls to the app, which is the products page, so that's the landing page, and I want to only allow a service account called sleep, and then a service account called the Istio Ingress Gateway. So if I apply this policy, boom. And if I go back here, I can still restart my page, right? So it works. That's basically the Istio Ingress Gateway talking to the products page. And then I can verify from the command line that I have here also like a couple of pods that are deployed. One of them is called not sleep, and the other one is called sleep. You remember in the policy, I allow the service account called sleep. So the service account here is attached to this pod. So if I try to talk from this pod to the products page, I should be allowed to. But if I try to talk from this one, I shouldn't. So we can go ahead and test that. So I'm just going to do a kubectl exec from inside the pod called sleep toward the products page. This should work. And then if I try from inside the pod called not sleep, I should get like an error because I'm not authorized to do that. So this is essentially very basic authorization policy based on principles. And I can implement all of that through the Z-tunnel without requiring any extra like sidecars, any of the stuff that Istio typically requires. Now, before I move on, how are we doing on time? Okay, we're good on time. For those of you who have never touched Kubernetes, so this is essentially what I showed so far is Ambient Mesh at a very basic level, right? It's architecture, sidecars doesn't exist anymore or are not there anymore. zTunnel is implementing L4 stuff, and then a waypoint proxy implements L7 stuff, which I'm going to show later. The other thing which is happening also with Istio, the project, the open source project, is that they are, for Istio, when it was created, it had its own set of APIs, right? Which is what you're looking at right now. So this is an example of how you would do traffic management in the current version of Istio. So if you want on the current version of Istio, you have service A, and then you have service B, version 1, and then you have a new version of service B, so V2. And you want to do, I want 95% of my traffic from service A to go to version 1 and 5% to go to version 2, right? So in Istio, you would have to do two things. You have to create what we call a virtual service and a destination rules. So what destination rules is, it's essentially gives you the possibility to create virtual destinations. So you know that in Kubernetes world, if you have service A and service B, so pod A and pod B, you would create service A and service B, which is the Kubernetes service, right? And then the Kubernetes service gives you like a single IP, so A can talk to B, and then it also gives you like an entry in DNS. So you can make A call B on name of the service dot the namespace dot svc dot cluster dot local. In Istio world, they came up with this new object called destination rule, which allows you to declare to say, well, version service B has two subsets. There is version 1, which has a label, and then there is version 2, which has a label. And then you would use a virtual service to do, for example, canary deployment, which is 95.5. So you would say, for all the traffic going to service B, I have two destinations. One is service B version 2, 5. So this is 5% going to service B, version 2 of service B. And one is 95 going to version 1, right? And so these two objects will give you canary deployment. The issue here is that those are CRDs, right? So they have to be installed. You have to install them. And usually they are installed as part of when you install Istio, right? They are very specific toward Istio itself. And they are only used to configure Istio. And they are sort of very complicated to understand. Like if you're not really into Istio quite heavily, this kind of sounds and looks like gibberish. And also that means that the Istio community has to maintain this stuff, right? So independently from Istio, we're gonna leave Istio on the side for now. And I'm gonna talk a little bit about something called the Gateway API. So in Kubernetes, the Gateway API is a new API that was developed, started development back in 2019, and now it's beta in Kubernetes, but it's started to be ready. A bunch of companies got together. This was KubeCon 2019 in Barcelona. And they decided, well, we have the Ingress API, which I think you're probably familiar with if you're using Kubernetes, but the Ingress API is sort of lacking. It's lacking a lot of features, and every single implementation of the Ingress API in every single cloud provider has like tons of annotations that you have to add in order to implement useful stuff, right? And what ends up happening with the Ingress API is that if you want to do something more complex, like header-based forwarding, for example, where people just don't use Ingress, they deploy something like HA proxy or Nginx because there was a lack of features built into the Ingress API. So the companies got together and they created a new API called the Gateway API. The Gateway API is supposed to be a replacement of the Ingress API. It is not right now. It's in the process of becoming that, and it's going forward the direction. The Gateway API has a lot of advantages. One of them is it works cross namespace. So with the Gateway API, there are a bunch of objects that got created. There are three main ones, so Gateway class, Gateway, and HTTP route. So the Gateway class is a platform-specific or cloud provider-specific object that defines what kind of load balancer you are deploying when you choose class 1 versus class 2. So this should be available in the cluster for you. Then you, as a platform admin, you would create a gateway, and the gateway is the actual load balancer, right? Then you would allow your users to basically use the same exact gateway through an object called HTTP routes, and then route traffic through their service through the load balancer. This is quite different than Ingress, because with the Ingress API, everything has to be in the same namespace, and you don't have this division of responsibilities. So this is an example where you have a gateway, a namespace owned by the cluster operator. The namespace will define a set of gateways. So this way, this is like gateway foo. The domain is foo.example.com. Attach some TLS certificates, attach some policies, etc., etc. Then as a developer of the store microservice, I can just create an HTTP route to say foo.example.com/store forwards to these services. And then as a site developer, I can do the same thing, right? This is how the HTTP route object looks like. So you have an HTTP route object. It defines, it has a name, it has a label. And then one thing you will notice here, so one main thing that HTTP routes are supposed to be doing is implementing natively some traffic management. So here's an example where we have an HTTP route which does matches on a header. And if the header is canary, it forwards you to version 2 of foo. Otherwise, it forwards to version 1 of foo. So if we look at this portion here, and we compare it to this stuff here, well, we could potentially take these two objects, merge them together, and just use the gateway API to implement the same functions of the same features without having to learn how virtual services work, how destination rules work, etc. And since the gateway API is going to become kind of native in Kubernetes going forward, so the idea is, why don't we just use the HTTP route or use the objects that the gateway API implements to also configure traffic in a service mesh? And that's the whole point of this exercise. Essentially, what's going on is that the Istio community decided we're going to invest in implementing our traffic management in the gateway API using the gateway API objects. And we're going to eventually, at some point, just get rid of all our objects. So there will be no more Istio-specific objects, no more Istio-specific APIs. Everything will be done through the same set of objects which already exist in Kubernetes. So namely, the gateway API, HTTP routes, etc. So I'm going to show you how that looks like real quick. And we can pause and if there are any questions. So I'm going to go ahead here and switch to the other cluster. We have another cluster. Again, same setup. I just have Istio Service Mesh deployed in here. And you will notice, no, you notice anything, sorry. Then I have the same app deployed, right? There is here waypoint proxy. We'll get back to it in a second. So first things first, what we can do is I had to deploy the CRD myself, etc. That doesn't matter. So what we can do is we can go ahead and label the namespace. So the namespace is labeled. The app just works, right? So what I can do is I can, for example, do this. So just 1 second before I move on. kubectl gets pods. You see here, for example, I have the reviews. I have 3 versions, version 1, version 2, version 3. There are like 3 different pods. So what these 3 versions does is basically they just change these colors here. So one is like plain text, one is red, and one is black. And what I can do is I can create an HTTP route that says, for the review service, which listens on port 9080, I want 90% of traffic to go to version 1, and I want 10% traffic to go to version 2. I can switch it to 50-50 just for the sake of demo. And then I can apply that. Boom. And now if I go back to my app and I refresh, I should be getting, I should be getting between no reviews and reviews. So no stars and stars. So 50% of traffic goes to version 1, 50% of traffic goes to version 2. Sorry. So here, you can see here, it says reviews served by, and it tells me which pod is returning the reviews. So if I refresh here, it says review 1. If I refresh again, it goes version 2. And then it should be about 50% of traffic. So in other terms, what the gateway API is allowing us to do is essentially use those existing objects that are anyway going to be becoming default in Kubernetes to do route management, right? Instead of having to learn all these existing or the pre-existing Istio objects that used to be that exist in the current implementation of Istio. Then let's talk quickly about this waypoint proxy, which I think is important. Istio alpha. No. So Istio alpha, good. Let's do this one. I want to do this one. Let's see. X, Y points, kubectl, and get pods. Let's see the one that I have already deployed. Yep. So let's do this one. Delete that. No, this one. I'll delete the other one. Book info reviews. Come on, what's happening? Give me 1 second. Yeah. I have to specify the service account. Okay. I have enabled this. Okay, let's see. Okay, so I have the waypoint proxy. What is this going to do? kubectl get points. Okay, so I have created the waypoints. You remember earlier I showed you in the slides this idea of waypoint proxy, this one here. So the way you would implement it today is using the issue_ctl command line, and then you can just apply a policy or a waypoint on a service account. In this case, I want to apply it on the products page. So that's the landing page. And so if I try to do this call from the sleep, it will fail because the policy does not allow me to actually talk from sleep. So if I look here at the policy itself, I have actually added, so applied another policy which says that the principals that are sleep and the issue ingress gateway can only execute a get operation on the destination, which is the products page, right? So if I try to do anything that is not get, like for example, I am trying to go from sleep and execute the delete, this should fail because the policy only allows me to execute a get. If I try to go from not sleep, it should fail because the policy does not have the not sleep principle, right? But if I try to go from the sleep pod and do a get, then I should get an answer, right? And so this is essentially the same authorization policies we saw earlier, except that earlier the authorization policy was only based on the identity. Now I can add an HTTP operation, and that's enforced through the waypoint proxy. The waypoint proxy, because it's a layer 7 proxy, it's able to actually look at the request and intercept the actual request inside and see if it's a get or whatever. So this is how typically, if you have used authorization policies in Kubernetes, that the authorization policies in Istio, they allow you to do these kind of things. But now we have kind of 2 layers of authorization policy. We can have one which we can enforce at layer 4 using identities, and then we have one we can enforce at layer 7 using more rich features like HTTP requests, etc., etc. And that's basically it. That's all I had for you. I showed I showed the traffic management parts, and yeah, that's it. That's all I had. I'm not sure you have any questions. If it was clear, if you didn't understand anything.
Thank you very much, Abdel.
Thank you very much.
It was very interesting. Yeah, I have just one question for you.
Yes.
How do you see the gateway API? It's a replacement of the ingress gateway. It's a
yes, pretty much. Yes, that's
the standard way to go.
That's the direction in which at least we are going, right? As Google.
Yeah.
So the gateway API actually has a lot of features that people are asking for, and that you cannot simply. So here is the problem. The problem with the ingress API is that if you want to implement it on, first of all, the ingress API in its current design, it was designed to solve the low-level common set of problems, which is I want a load balancer, and I want the load balancer to listen on port X to have this SSL certificate, and I want to be able to do this kind of traffic management, but very high level, like /API go to this backend, /something go to this backend, /something go to this backend. You cannot do header-based mapping. So you cannot say if I have a header which is testing, I cannot do that in the Ingress API. If I want to have canary deployment, cannot obviously be done. These kind of things, right? So because these features are lacking, the Gateway API trying to implement this stuff in a native way. And when I say a native way, essentially using the HTTP route objects, you can implement all this like header-based routing, all this canary deployment routing, all that stuff. So basically what's happening, what exists today is that upstream, so in the Kubernetes project open source, the Gateway API is beta. The HTTP routes is beta. They are working on a couple more routes, so a couple more objects. There is one called TLS routes. There is one called TCP/UDP routes. And there is one called something else, I forgot. There are a couple of more objects that they're working on. And then as far as cloud providers implementation is concerned, we have a controller, and our controller is GA. So you can implement today the Gateway API on Google Cloud integrated with the GCLB, Google Cloud Load Balancers, and that's the controller is GA. And then the stuff that Istio is doing, because Istio is basically what they're doing is just they're looking into how they can reuse the stuff that the Gateway API allows them to do to get rid of their own objects. They essentially don't want to maintain code, right? So they're like, if we can avoid having people deploying extra CRDs, it's better, right? So to answer your question, yes, eventually at some point there will be no more ingress, or at least as far as we are concerned, we are gonna sunset ingress in favor of the Gateway API.
Okay. So now we can use the Gateway API if it is already beta.
On GKE, you can use it today. On GKE, it's, I mean, so here is the deal. Like the progression of APIs on Kubernetes, so when they go from alpha to beta, beta to GA, on the Kubernetes side, they have their own process to upgrade APIs, right? But as far as we're concerned, what we are developing is the controller. It's the part that integrates the Gateway API with our APIs, right? That controller is GA. The Gateway API itself is beta. There are quite a lot. There are tons of APIs in Kubernetes which are beta.
Yeah,
exactly. Use them in production, right? So no one really cares.
You guys in Google, all your services are beta.
Exactly. No, but like even in Kubernetes itself, there are quite a lot of APIs which are beta in Kubernetes, and people use them, right?
Yes.
So, but there is a lot of investments going into the Gateway API even upstream. I will not be surprised personally if I see it becoming GA in maybe 2 or 3 versions. Upstream, I'm talking, not the controller.
Okay. Fantastic. And yeah, what is your recommendation working with you guys at Google? You provide also APG for API management, and APG provides an API gateway.
Yes.
So the Gateway API, it's the entry point to the service mesh, to the cluster, sorry, and we can use them both. We can have APG on top of the Gateway API.
Yes, I mean with the Gateway API, you are gonna end up having a load balancer, right? So you can expose your stuff using load balancer the same way you used to do with Ingress. And then you can configure APG to act as an API management layer and forward traffic toward your load balancer on GKE, right? Actually, the pattern that we recommend customers to use is to use Cloud Armor, because when you are configuring, I don't know, because so I don't follow APG that much, because I know that they have this new thing called hybrid, which runs on Google Cloud. So like you can run, APG X, right?
Yeah.
And so I'm wondering, like, can you use PSC, Private Services Connect, there to connect the VPC where the proxies run, the VPCs where the APG proxies run to your VPC?
Exactly.
Yes,
Because
I guess this is, sorry to interrupt, Abdelfettah, but I guess this is one of the main solutions to deal with separate VPCs when using APG. APGX mainly, or ps_uco version.
Yeah.
Either you have to use a shared VPC and you put everything, all your workloads inside this shared VPC, which then connects to the VPC created by APG instance. Yeah, it's they do a VPC peering, and you cannot do You cannot do, yeah, it's out of the box. It's a VPC pairing between RPG and our VPCs. So either you have to do, because VPC pairing is not transitive. So you
Yeah, I
can
don't
have
like VPC
either,
pairing anyway.
yeah, it's
I'm
not
a big fan.
transitive. It makes a lot of problems. So you have to either have one shared VPC or use PSCs, Private Service Connect, to directly connect to
Yes.
some services like a load balancer or something like
Yeah,
that.
so that was my question. Like with RPGX, do they have support for PSC? Because
Yes.
the way I used to do it, the way we used to do it with customers, when RPG was not hosted on Google Cloud, so when the the SaaS version of RPG was hosted basically outside, it was hosted in the cloud. It doesn't matter. What we used to tell customers to do is deploy the ingress, configure the cloud armor, and then you can actually only, because the RPG can give you egress IPs, so they can give you static IPs for the traffic coming from RPG, and you can configure those with Cloud Armor to only allow these IP addresses to talk to the load balancer, right?
Yeah.
So this was one pattern.
Yeah, they have something called endpoint attachment that they added, and you can list all your PACs there, and
Okay.
out of the box it can connect directly to your workloads.
Then if you have if it can support PSC, I would recommend to go with PSC. PSC is eventually going to replace peering as well.
Yeah.
Right. I hope that answers your question.
Youssef?
Go ahead. I have a question about the ambient mesh.
Yes.
What is the status now? We can use it. We can try to use it, or for
you can try it out. Don't put it in production.
Yes,
it's still in experimental. So in Kubernetes one. So I didn't show it actually in the demo, but in Istio 1.18. By the way, I used Istio 0.18 alpha, which is like the the alpha release. But in Istio 1.18, I don't know if anybody here, if you have deployed Istio before, you know that there is this thing called profile, right? When you run the Istio-ctl command line, you have -- set profile, and then you can deploy the minimal profile, the default profile, blah, blah, blah. There are a bunch of options. They added a profile called ambient, and that's how I deployed it in my case, right? I just had to download the alpha version of the CLI, because it's not out yet. 1.18 is not officially out yet. So I downloaded the alpha version of the CLI, and I used that to deploy ambient using the ambient profile, right? So it works. In my experience, it works very well. I have never had glitches with it. I had more glitches with 𝐭𝐬𝐡 itself, but that's the way 𝐭𝐬𝐡 is set up. You need to open like a specific port on the firewall so you can talk to the control plane. It's all documented in the Istio documentation. It's just a little bit hard to find. If you don't want to use Google Cloud, just deploy Kind or Minikube locally and test with that. It will be easier probably. But yeah, do not use it in production, unfortunately.
Okay, thank you.
Okay.
Yeah. And there was a comment on the chat by Lam Ara. It says plus API gateway allows traffic management across K8s clusters. So yes, that the gateway API has also a lot of you can do multi-cluster with the gateway API much better than you can do it with the ingress. So you can have a single load balancer sitting in front of multiple clusters if you want, like, cross multiple clusters across the world, so you have low latency for users and you have regional high availability and stuff like that.
Yes. Excuse me, please, about this question.
Yeah.
I don't know what is the limits of the API gateway, because you have started thinking about centralize the way how to expose our all applications.
Mm-hmm.
So we have many applications, about 50 applications, and we start asking about how can we using the API gateway to centralize them. I don't know if this is possible.
You mean centralize the load balancer, right?
Yes.
So have a single load balancer, and then you have paths, and each path.
Yes, within one GCP project, and which we direct all the traffic to all the other projects.
Ah.
Yes. I don't know if this is possible. Actually, we started thinking about this.
You could do it. You could do it on if you're on GKE, you could do it, but you need to use this thing called MSC, multi-cluster services.
See.
So MSC is it's not open source. It's proprietary. It's our own controller.
Okay.
With MSC, basically what it does, it gives you services across clusters, right? So you can create a service in one cluster, and then you can create what we call an export. So you export the service, and then you create an import in a different cluster. So you have a service that sits in cluster A, but you can talk to it from cluster B.
I see.
So you can use this in addition to the gateway API. So you would create all the service imports in the same cluster where the gateway API is deployed, right? And then all the destination services themselves are in different clusters. But then in your gateway API cluster layer, that's where you will have the load balancer deployed through the gateway API, and you would have the HTTP routes. And then the HTTP routes, they will point to the services which are imported.
I see. Okay. Yes.
Just look into it, like service import, service export. I can. There is a repository in which we try to document some of these examples. Let me share it with you here. If you don't find an example for doing that there, just open an issue and describe what you want, and we'll see if we can look into it.
Okay, thank you. Because you have already started using it, but within one cluster with multiple applications. But cross clusters, we still have some issues actually. It's just experiments, and yes, this is interesting actually to see the MSC feature. I will check for it. Thank you.
Yeah, it sounds like something we should be able to do, or we should at least be able to document. It's an interesting use case.
Okay, thank you.
No worries.
Okay, I think it's good. Thank you so much, Abdel, for this very interesting talk.
Thank you, folks, for having me.
Good. Bye-bye and bravo.
Thank you. Take care.
Thank you, Abdel.
Thank you so much.
Bye.
Take care.
Merci.
Bye-bye.
Bye-bye.
Thank you.
Thanks, guys.